Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. We are in Unit 7, and today we're looking at lessons 10 and 11, modeling with linear inequalities. So this whole unit we've been talking about these linear inequalities. Today we're going to see how we can use those to model situations. And this first question here is just asking us to look at this inequality and say if this point that they've given us, or this ordered pair 3, 2, is a feasible solution. Is it a reasonable solution for that inequality? And so all we need to do to determine that is we're going to plug in those values for x and y. So 2 times 3 minus 4 times 2. So this is the x value, this is the y value. Needs to be less than 0. Well, 2 times 3 is 6. Negative 4 times 2 is negative 8. And so we get 6 minus 8 is less than 0. 6 minus 8 is negative 2. Negative 2 is less than 0. So we would say, yes, this is, that 0.32 is a feasible solution for the inequality. It would be in the shaded area of that inequality if we graphed it. All right, our second question here says that a carton of a dozen white eggs costs $1.75, while a carton of a dozen brown eggs costs $2. Julia can spend up to $8 to buy 3 white egg cartons and 1 brown egg carton. Let X represent the number of white egg cartons and Y represent the number of brown egg cartons, and then we're going to draw a graph to model this problem. Well, really what we're looking at here is we're calling the white egg cartons X, and so each white egg carton costs $1.75. Each brown egg carton, which we're representing with Y, costs $2. And so if I take the number of white that I buy times $1.75, the number of brown that I buy times $2, we're saying that that value or that needs to be up to $8, so less than or equal to the $8 there. And so since it asks us to graph this, we can go ahead and I'm going to pull over my Desmos graph here. So I have plugged that inequality into Desmos, and you can see the graph that it creates. So any combination that's on that line, this is a solid line, anything shaded below are combinations that she could buy. Now, we would want to stick, since we're talking about cartons of eggs, we would want to stick to whole numbers. So the only reasonable solutions are going to be ones that are whole numbers. So for example, so my x-axis, or x we said was the white cartons. So if she bought 3, and it looks like it froze up on me, but if she bought 3 cartons of white, then she could buy 1 of brown. She could buy 2 of the white and 2 of the brown because that's still in that shaded region, and so on. So, so that's how we could go about graphing that. All right, and number 3, or our third problem here, asks us to write and solve a linear inequality for this following situation. It says 4 times 6 less than a number is less than or equal to 3 more than twice a number. All right, so we'll use an n this time to represent our variable. So we're going to take 4 times 6 less than that number. So 6 less than n would be n minus 6. We're going to multiply that by 4. So it says 4 times 6 less than a number. That is going to be less than or equal to 3 more than twice a number. Well, twice the number is 2, so 2 times n plus 3. All right, so that's the inequality written. It also asks us to solve it. So I'm going to start solving it by distributing that 4. 4 times n is 4n. 4 times negative 6 is negative 24. That's less than or equal to my 2n plus 3. I would next want to get my variables on one side, so I'm going to subtract this 2n from each side. And that leaves me with 2n minus 24 less than or equal to 3. Now I'm going to bring this up here to do my next step. I'm going to add 24 to each side, which leaves me with just 2n on the left side. And then adding 24 to 3, I get 27. And then my last step would be to divide each side by 2. And so I get that n is less than or equal to 27 halves. I could write that as 13 and a half or 13.5. But so that n has to be less than or equal to that value to make that inequality true. All right, one more problem here. It says we have two rideshare companies that are offering different but competitive prices. Company A is charging $8 to send a vehicle and $2.50 per mile to drive you to a destination. Company B is charging $12 to send a vehicle and $2 per mile to drive you to your destination. And so we want to know how many miles long X, so X is representing the number of miles, can a drive be for company B to be the cheaper option. All right, so if we look at company A, they're charging $8 plus $2.50 per mile. So $2.50 times X is our number of miles. We want to know, when will company B be cheaper than that? So we are looking for, when is this going to be greater than company B? And company B is charging $12 plus $2 for each mile. All right, so that's our inequality to start. Let's go ahead and solve it to figure out how many miles it is for company B to be the cheaper option. All right, so we're going to start by getting our variables on the same side. So I'm going to subtract the 2x from each side. And that leaves me with 8 plus 0.50x greater than 12. Then I need to subtract 8 from each side. That leaves me with 0.50x greater than 12 minus 8 is 4. And then we're dividing each side by 0.50. 4 divided by a half is going to be 8. And so, and I should say not equals, that should be greater than. So if your drive is longer than 8 miles, then company B is going to be your cheaper option. All right, and I believe that is our last problem on that one. It is. That is all I've got for you today. Thanks for taking the time to watch. As always, please let me know if you have a question, and have a great day.